Hi everybody, today the topic is quadratic trig equations. Now if you look on the top line, it has ax squared plus bx plus c equals 0, where a, b, c are the real numbers and a is non-zero. That is your traditional quadratic equation. The only difference between that and your quadratic trig equation is that instead of it being an equation involving a variable x, it is now an equation involving a function, this being sine. It doesn't always have to be sine, it could be cosine, could be tangent, could be secant. And similarly, it doesn't always have to be quadratic either, you can get other types of trig equations. But these are the ones that come up a lot, particularly in Core 2. And sine tends to come up more often than cos, but you could do cos just as easily using the same principles. So anyway, there are two steps to solving anything like this. The first step is to find the values of sine x that satisfy the equation. And I put there, if you write s equals sine x, that can help sometimes. And then you have to find the values, and I've underlined the s for a reason, of x that correspond to the values of sine that you've determined. Because for every value of sine, there are infinitely many for every value of sine between -1 and 1 inclusively, there are infinitely many values of x, which could be the pre-image. So anyway, here's an example. Find the solutions of 2 sine squared x minus 3 sine x plus 1 equals 0. Now often the question will tell you an interval, so in this case I put an interval x between 0 and 2 pi. Underneath that's just a different notation for the same thing. Right, so the first step is to find the value of sine, which I've found here. It's 1 or it's a half. So then you have to find the values of x, which give you sine x equals 1 or sine x equals a half. So that's what the next step is. Like that. So if we draw this graph of sine there, and then here we have it. So inverse sine of 1 is pi over 2. Now you don't really need your calculator to know, that's just something which you should know off the top of your head. And then similarly, the inverse sine of a half is pi over 6. Now, knowing that sine of pi over 6 or sine of 30 is a half is just something you can learn. But if you don't manage to remember that, most calculators have an inverse sine function. And the 5 pi over 6 simply comes from the fact that the curve has a symmetry to it. So that's fairly simple. So anyway, there you now have three values in the interval specified. Anyway, moving on to the next part, the general solution. Because they won't ask you for this in Core 2, but I've got a feeling higher up, particularly in further maths, they'll ask you for the general solutions of equations like these. So we'll take the example we had before, 2 sine squared x minus 3 sine x plus 1 equals 0, equivalent sine x equals 1 or a half. So we'll plot the sine curve again, but instead of plotting it between 0 and 2 pi, we'll extend it much further. And then here are all the different values. So if you start with pi over 6, you'll notice that whenever you find a pre-image of sine, in this case the pre-image of a half is pi over 6, then it repeats itself at every multiple of 2 pi. So if you move 2 pi to the right, the value is the same, which is why you have pi over 6, then 13 pi over 6, then 25 pi over 6. Similarly here, sine of pi over 2 equals 1, therefore sine of 5 pi over 2 is 1, because that's 2 pi after it. And similarly, sine of 9 pi over 2 is 1. And then we know that sine of 5 pi over 6 is a half because of the symmetry of the curve. And now because sine is periodic, yet again, you can add multiples of 2 pi, and you'll get that sine of, what's that? Sine of 12. No, 17, that's better. 17 pi over 6 equals a half, and that sine of 29 pi over 6 is a half. So to give a general solution, you have to find a way of giving that in the most general sense, which I've done here. Should be down here, which I've done here below. So you got pi over 6 plus 2n pi, which is the same as 12n plus 1 lots of pi over 6, where n varies throughout. Z is the integers. And similarly, 5 pi over 6 plus 2n pi, which is 12n plus 5 lots of pi over 6, yet again where n varies throughout the integers. And pi over 2 plus 2n pi, which is 4n plus 1 lots of pi over 2, where n varies throughout the integers. So that is the general solution of the equation, instead of being more specific or confined to an interval. The only other case you have to think about now is when there are no solutions. And there are two main reasons that might happen, so I'll put them here. If the absolute value, if when you complete the first part of the question and it tells you that the value of sine is either greater than 1 or less than -1, that's a contradiction. That can never happen. Both sine and cosine are bounded in the sense that it can never be less than -1 or greater than 1. So you'll have no solution. And then, as with traditional quadratic equations, if you take the discriminant, i.e. b squared minus 4ac, if that is less than 0, then you won't have any solutions either. And so that is the general theory of how to solve a quadratic equation in terms of sine x. And that method can be generalized further, and you can use it to solve equations in terms of cosine, secant, and tangent functions, as well as possibly inverse trig functions as well. There's no reason why you couldn't do that. As I say, they don't have to be quadratic either. They can also be cubic. I think I remember seeing some of those type of questions out there. So, but nevertheless, this kind of paradigm is the wrong word, but this method will work in the most general sense possible.